Okay, good day everyone. So this is a pre-recorded lecture for the geodetic surveying subject. So at this time, we are now on the third chapter, which is on a fourth chapter, which is on the horizontal geodetic control positioning or method, which relates on the focuses on the triangulation. So basically, in this chapter, we are going to discuss what are those corrections, what are those required computations that needed before, after we design, and then we do the sum computation. So it is a one of the procedure in conducting a geodetic control. So we need to apply some computations, apply some corrections to enable to have a good accuracy of our data. So basically, we have here the outline of our meeting this today. We have here, we are going to define or some basic terms which are going to use in the triangulation. We have the purpose, what is the purpose of our triangulation, and other than the trilateration, some definition of terms, the procedure in conducting the network and designing the network using the triangulation method. So basically, the method which was applied back then, which is triangulation, they use the total station. It needs to cover the intervisibility of station, need to correct the excess, you need to correct or reduce the measurement to center, and so on. So we are going to discuss also the what are the figures of the triangulation, what are the best choices, or what are the best choice of figures. We are going to design our network for the triangulation, discuss some adjustment, and we already done the activity last time, which is you adjust some of the angles based on our lab exercise number 3, and adjustment of the chain of the triangle. So I'm going to again review of the methods for the adjustment of quadrilateral and the strengthened figure in the trilateration. So for the triangulation procedure, we are going to focus on the triangulation procedure because there are a lot of computation here in the last part of the triangulation procedure. So we are going to discuss the intervisibility of station. How are you going to compute if one point to another point cannot be seen because of some obstruction? And then other than that, we're going to discuss some of the application of spherical excess in our geodetic control network, reduction to center, reduction to sea level, and last one will be now the adjustment of our quadrilateral. Okay. So let's start with the purpose of the triangulation and the trilateration. So again, this is employed extensively to, if we are going to establish horizontal control. So this is the main for triangulation. If more or less our angle is measured than the distance, and the trilateration if we measure the distance more than the angles. So this, the purpose of why we employ triangulation other than the establishment of control is that for topographic mapping, if we want to determine the topography or the relief of the ground, we have charting lakes, rivers, and ocean coastline. This is also applicable in the hydrographic surveying. So since you are enrolling the hydrographic surveying, so this will be also applied, the method of triangulation, and the service required for the design and construction of public and private works of large extent. So this number 3 here, the geodetic control network design comes in. So if you are going to deal with a large project, such as cadastral projects, road projects in which we need to have a geodetic control or a project control and establish those points on the ground. So before we establish, we need to design, and after we design, we need to conduct ocular inspection on the ground if it's possible or impossible to occupy the points which was designed. And there should be certain computation and adjustment of our data before we establish exactly the mohon or the control on the ground. So let's have here some definition of terms. So I know you are more familiar with this one. We have the triangulation. If um, we have a series of joined or overlapping triangle in which occasional line is measured. So pwedeng dalawang measure in a quadrilateral, isang line lang yung i-measure or dalawang line, that's base and the baseline, it will do. But all of the angles are calculated and measured on the during the ground. So mas dinetermine yung angles on the ground, and then the lines is kino-compute na lang siya after the angles is being corrected. We have here the triangulation. The vertices of the triangle in a triangulation system. So ito yung mga station ng ating triangulation system. So yung mga corner ng ating network. So those are called the triangulation station. We have here also the baseline. So yung baseline is ito yung mini-measure na line in our network. So it is a line whose length is precisely measured. If you remember on the standard set by the DAO or the DMC, that our baseline should be measured twice, thrice, or more, depending on the accuracy of the survey that we need to. And the direction is determined by astronomical observation. So this can be applied pag nag-astronomical observation, pag yung ating position mismo ng ating isang endpoint, if this is A and B, ito yung ating magiging baseline. If the position is not already given on one point, so you need to observe through astronomical observation to determine the latitude and the longitude of the point. Okay, so usually located at the beginning of the triangulation system, as the same to your activity last time, to determine your the length of your baseline, and it's used as the basis for the computing the lengths of the other lines. So take note that we are dealing with the triangulation. So if we want to measure the lines on the next quadrilateral, then we need to have precise measurement of at least 1 to 2 lines. So this is called the baseline. In order also to check if our computation and our observation of the angle is correct, then we need to have a check base. So what do you mean by this check base? So yung check base natin is mini-measure din siya precisely. What is the importance of having a check base? To determine if our computation is correct, our adjustment is correct. So if we see a very small differences between our check base and then in our computation then we can say that our work is more or less precise. Okay, so for the definition of the trilateration, so this also if we measure more on the ground the distance than the angle, so that means the trilateration. So when we say triangulation, we measure more on the angle, and then the lines is being computed na lang with one baseline and a check base. So in this illustration here, let's say for example, this is the baseline. So they set the baseline as AB. So for the triangulation, we only measure AB, then we measure the angle here. This is angle A, angle B, then angle C, angle D, E, F, and so on. So we measure all the angles, and we may, like for example, if this is the whole coverage of your project, so you have here the check base. Since we don't measure the angles here and the distance here, I mean, we don't measure the distance from D to E, E to F, but we need to determine the distance, then we employ some computation. Since we already have the distance, then we simply use the sine law, cosine law to determine the distance here, right? Since we employ triangulation. So in our sa baseline pa lang, pag na-establish tayo ng baseline, we don't know the direction and of our line, we don't know the azimuth and the bearing. That's why it needs to conduct astronomical observation if we only use a total station. But if in advancement, if we use RTK, so no need for the astronomical observation. Also, if there is another existing point, like meron siya ditong another point which is known, so you can take a backside just to determine to set the direction of your proceeding line. So you can take a backside. Pero kung walang point kung saan ka magpa-backside, kung walang ibang fixed point, then you really need to observe and determine the azimuth of the line by astronomical observation. Okay, so this corner, the corner of our quadrilateral is known as the triangulation station. So this is the point where the observation is being observed and the point is being occupied. So kung saan yung ating instrument nilalagay yung instrument. So these are the triangulation stations. Okay. Okay. So let's start with the procedure of the triangulation. Just an overview how the triangulation procedure is being employed in the ground. We have the triangulation figures, the choices of our figures, and the triangulation adjustment. So as you can see on the background of this slide, so there's an example of a wide range triangulation projects. So meron siyang mga points in between. So these are the vertex of the known as the triangulation station. So these are example of a network. So let's start with the procedures. So this started with the reconnaissance. So during the reconnaissance, it includes the procedure on yung pagbiling ng mga existing na mga control point, and then pag-design mismo ng geodetic control. All of the things that needs to be checked is done in the reconnaissance. Yung parang, ano siya, paano ba to? Parang ocular inspection on the ground. So, to determine kung okay ba lagyan yung mga points sa ground, then that is being done on the reconnaissance na part. So, pag na-establish na yung design, then next to that is error propagation or strength of figure of the network. So if pag na-establish na yung design, then we are going to determine the strength of figure. So we are going to discuss that one on the determination of the strength of figure, and then the erection of signals of tripods or towers. So just in case if the points on the ground, it's impossible to impossible na hindi intervisible yung each point from the other point, and then establish na yung strength ng figure, which means yung design is parang final na siya, and then they find out na hindi pala intervisible yung mga points, then they are going to establish mga towers just to make it intervisible yung mga points. So this only applies on the method of pag walang GNSS or walang GPS. So they employ erection of towers or signals. We have here direction or angle observation. Then they started the observation on the ground to determine to measure the angle. And then they measure the baseline, measurement of the baseline. Astronomic observation to determine the direction ng mga lines, or maski yung direction lang ng baseline. And then we have here, we are going to focus on the computation. So for the computation, there are a lot of computation to be employed. So depending if it's really necessary, hindi naman sa lahat ng point ina-apply yung ating computation. So we have here reduction to sea level. So why we need to reduce our measurement to sea level. Since we are dealing with geodetic control, we care about we consider the curvature of the earth, including the refraction correction. So that's why we need to reduce our baseline, like for example, our baseline measurement, since medyo curve and then may curvature yung ating earth. And then during the observation, we measure only the horizontal distance or a plane. So we need to correct that. And we are going to reduce that into the sea level or yung ating level surface na observation. We have here reduction to center. Reduction to center is hindi siya ini-employ every time you observe on each corner. So this reduction to center is only applied if in such cases yung ating corner points is impossible siya ma-occupy. Like for example, naka-set sila ng design and then they found out on the ground impossible para malagyan ng instrument. Like for example, medyo dangerous yung ground or like sobrang hill na and then it's impossible to set up the instrument. Then we have here reduction to center. So this is one of the method na maglalagay ng isang point para doon na mag-occupy ng point. But then, i-observe lang yung ating original na point on the ground. So we are going to discuss further this one later on. We have the spherical excess. Since we are measuring the plane, pag yung ating naka-design na triangle, so imagine pag large extent na yung ating network, so what will happen to our distance? Medyo nagko-curve siya since our Earth is not flat. So we need to apply some spherical excess. So we need to determine the error. So we have the length and the coordinates. So after we determine the distance and angle of our network, then after that, we are going to assign coordinates of each of the corner of our station. Since yung ating mga control points is na may coordinate na siya, hindi pwedeng bearing distance lang yung ating ilalagay na information sa ating mga control. So we need to assign a coordinates of our control. So we have here network adjustment. So as you all know that during our observation, there is an error of the angles and it needs to be corrected with our side angle condition, the angle condition, diba? So it needs to be 180 and all the angles inside the quadrilateral and all of the triangles inside the quadrilateral is equal to 180. So for the network adjustment also, this is required if we are going to determine the strength of figure of our network design. Okay. So we have when I say triangulation figures, ito yung ano yung design, yung mismong design. So we have here in a narrow triangulation system, a chain of figure is employed consisting of single triangles. It could be parang tabi-tabing triangles lang. And then polygon, it could also mga square, tabi-tabing square. Similar yung exercise nyo. We have quadrilaterals and it could be a combination of the three. So a triangulation system extending over a wide area is likewise divided into figures which are irregularly overlapping and intermingling. So dapat nag-overlap yung ating mga network. So example ng chain of triangles. So you can use this one if masyadong narrow. Yung for example, pag road project, habang road project, then you can employ chain of triangles. But it does not provide the most accurate result due to the lack of checks. So let's move to the next figure, which is mas nire-recommend na design ng triangulation. We have here chain of polygon. So yung polygon lang depends on how many sides is the polygon. Consists of a central point. So like for here in example, yung central point niya is D. Central point niya is I, central point niya is M. But medyo complicated yung computation if you are going to employ the chain of polygon. The most recommended is the chain of the quadrilateral. So this is the same to the activities that you have done in the Google Earth. This is most commonly used for triangulation system. So in the Philippines, they employ the chain of the quadrilaterals. So this is adapted to long and narrow surveys of high precision. So this is parang tested na and proven na mas precise yung kanyang result. Okay? So to ensure the high accuracy, the triangulation system have an ideal shape and recommended distance angle. So that's why on your activity, I have some comments on the group in which yung kanilang shape ng quadrilateral is medyo hindi maganda because we have to compute the strength of the figure. Pag hindi maganda yung quality ng design ng network, it would determine mas magiging lower yung value ng strength of figure, and then hindi siya advisable na gamitin na design. So yung ideal shape is equilateral. When it's equilateral, pag triangle, all of the sides are equal. And for quadrilateral is more or less, yung isang quadrilateral is naka-square. Like for example, yung every angle is more or less 90 degrees. So magandang design yun. But anyway, we cannot be sure if those, maski gusto natin maging square, but on the ground, it's impossible naman maging square. But more or less, we targeted na yung design is magiging square. So distance angles are opposite of known are required sides of the triangle. So the recommended range is 30 to 150 degrees yung value. Less than 30 degrees na reading ng angle is not advisable. It is because during the computation, if we employ, pag nag-i-employ tayo ng sine law, pag nasa sine law, it really differs the value pag nag-change. So, madaling mag-change yung value ng sine law pag lower yung angle. So, yung dapat na angle is either 30 to 150. And then, recommended again is 90 degrees yung angle, yung total angle mismo ng corner ng isang quadrilateral. Okay? So, since yung quadrilateral, mayroong, di ba, yung angle A, B, C, D, E, F, G, H, parang H ata yun. Yung internal angles ng yung internal angle ng quadrilateral. If you found out that may angle kayo na less than 20 or less than 30, so I think yung magiging result ng strength of figure nyo is parang mababa, sobrang baba. And it's not advisable. Okay, that's for now for the parang introduction lang ng triangulation system. So next slide, I will be presenting you some sample problems on the intervisibility of stations. So this is only for part 1. So see you on the part 2.